Okay, so the factors of the strength of electromagnet depends on, as I said, the current, this time the number of turnings, and the distance between the pole. Alright, the distance between the pole. The nearer, the stronger. The further, the weaker it is. So these are the three factors. Okay, these are the three factors. Now, let's consider solenoid. I want you to look at the solenoid first. A solenoid is a cylindrical coil. A solenoid is a cylindrical coil. Cylindrical coil. Okay. This solenoid is positive, negative. It's long, and say assuming that it is, I'm going to use a 1 meter coil, very long, 1 meter coil. Alright, 1 meter coil, and then I am going to say that this solenoid is an ideal solenoid. When I say ideal solenoid, meaning what? Ideal solenoid meaning there is no loss of magnetic field. There's no loss of magnetic field. So if I trace the current from positive, like that, so by using your right hand grip, you see, right hand grip, going down, this is north, this is south. So this is north, this is south, alright, north and south. Okay, so when I say north and south, all the magnetic field will go like that and come back. See, 3 magnetic field going out, 3 magnetic field going in. Then we say the number of magnetic field coming out and coming in is the same. That is called an ideal solenoid. Okay, there's no loss of magnetic field. So the strength of both ends must be the same. Alright, so very important, the strength of both ends is the same. Alright, strength of the magnetic field on both ends is the same. Now with this 1 meter, I'm going to split it now into shorter. I cut it. Okay, I'm going to label this as A, C, and the B is the middle one. Okay, A, B, C, A, B, C. So I'll break it up into like this. This is A, this is B. And then I split it up again. This is B, this is C. Okay? Now, I just told you that both ends have the same strength. So, the strength of A and the strength of B is the same. If I split it into now 50 cm, 50 cm already. Because before that was 100 cm. 1 meter is 100 cm. I break it up into 50 cm, 50 cm. Or 100 cm into 50-50. So the strength of A is the same as strength of B. The strength of B is the same as the strength of C. So what is the conclusion? In the center of the solenoid, it has the strength of A. In the center of the solenoid, it has the strength of C. So in other words, the middle part has twice the strength of both ends. Alright, so in other words, in the simple solenoid like this, okay, conclusion is that number one, both ends have the same strength. Number two, the middle of the solenoid is the strongest magnetic field because it has both strength of both sides. It has both. Double. So, how to prove this? I'm going to show you one simple experiment whereby I'm going to put it on a plank. This is a plank, okay? And then on top of the plank, I have a small trolley. And this small trolley, there is a iron rod on the trolley. Okay, and this is a smooth plank. So with this smooth plank, what I'm going to do is I have a switch here. Until here is enough. Alright? And I'm going to close this switch. Observe what happened. When I close this switch, the current is going to flow like that, this way. Okay? So use your right hand grip. Alright? So this is north, this is south. So this part is north, this part is south. But regardless whether this is south or this is north, because iron is a magnetic object. Iron is a magnetic object, meaning it can be attracted to any permanent or temporary magnet. So when this is attracted, it will result the trolley to move to the right. When it moves to the right, because the center of the solenoid is the strongest magnetic field, it will move to be attracted in the middle. However, because the iron rod has mass and iron rod has inertia, it will not stop immediately. It will pass by and move halfway until here, look at my finger, and then stop, and is being attracted back again to the center because center is the strongest, and then inertia stops again and it will move to and fro with an amplitude of decreasing until it stops right in the middle. That is the observation. So I'm going to repeat one more time. Watch. It moves. It goes. Because inertia, attract, and then it moves in the center. So in other words, it will stop in the middle after several minutes. And what is the conclusion? It shows that the center of the solenoid is the strongest magnetic field. Alright? Strongest magnetic field. Okay? And always, we must always make sure that we use the, say, if I have a coil again, a solenoid, and this is also another solenoid, okay, but this time I'm going to use one is a copper. This is a soft iron rod. And then I close both switch after 5 minutes. I close it for 5 minutes. After I close it for 5 minutes, confirm it's going to be magnet. Correct? Both will become temporary magnet. So I remove it out, and then this is a copper, this is a soft iron, and I use all the thumbtacks. I put 2 thumbtacks here, and it is found that this is the pin of thumbtacks. It is found that both copper and soft iron will attract the peak. But what is the observation? You're going to see that this won't last long. It will drop. So what is the conclusion? The conclusion is that in electromagnetism, we always use soft iron because it is easily magnetized and demagnetized. It will not retain the electromagnetism so long, and that is the advantage of the electromagnet.